Ever gazed up at the night sky and felt a sense of wonder? Among those countless twinkling dots, one smudge of light holds a special significance. That's the Andromeda Galaxy, M31, our closest major galactic neighbor. But have you ever stopped to think, just how close is it? And if we were to embark on the ultimate road trip, how long would it take to get there? Buckle up, because we're about to journey to the edge of imagination. First, let's wrap our heads around the immense distance. The Andromeda Galaxy is about 2.537 million light-years away from us. A light-year, as you might know, is the distance light travels in 1 year. Light is the fastest thing in the universe, zipping along at a staggering 186,000 miles per second, or about 300 numerous kilometers per second. So, when you look at Andromeda, the light hitting your eyes began its journey 2.5 million years ago. Dinosaurs were long gone, but our early human ancestors were just starting to roam the Earth. You're literally looking into the distant past. To put this cosmic gulf into perspective, let's try to cross it with technology we actually have today. Imagine hopping into one of the fastest spacecraft ever built by humanity, the Parker Solar Probe. This incredible probe has reached mind-boggling speeds of over 430,000 miles per hour. That's fast enough to get you from New York to Los Angeles in under 20 seconds. If we pointed the Parker Solar Probe straight at Andromeda and hit the gas, how long would our trip take? Get ready for this. It would take approximately 3.9 billion years. Yes, billion with a B. To put that into perspective, our own sun is only about 4.6 billion years old and has about 5 billion years left before it becomes a red giant. So, by the time our probe arrived, our solar system as we know it might not even exist anymore. Okay, so conventional rockets are out. What about something a bit more futuristic? Let's talk about hypothetical technologies. A popular idea in science fiction is the ion drive, which uses electric fields to accelerate ions. While they have very low thrust, they can accelerate continuously for years. NASA's Dawn spacecraft, which used an ion engine, reached a top speed of about 25,000 miles per hour. At that speed, the journey to Andromeda would take, well, even longer. We're talking tens of billions of years. Clearly, we need a bigger leap. Let's dream a little bigger. What if we could travel at a significant fraction of the speed of light? Say, 10% the speed of light. This is far beyond our current capabilities, but let's just imagine. At this incredible velocity, the journey would still take over 25 million years from Earth's perspective. However, something fascinating happens when you travel that fast. Time dilation, as predicted by Einstein's theory of relativity. For the crew on board the spaceship, time would pass much more slowly. So while 25 million years pass on Earth, for them it might feel like a slightly shorter, but still unimaginably long, 24.8 million years. Still not a weekend trip. Let's push it even further. What if we could travel at 99.99% the speed of light? Now we're talking. The trip would take, from our perspective on Earth, just over 2.5 million years. Basically the same amount of time it takes for its light to reach us. But for the astronauts on board, thanks to extreme time dilation, the journey would feel like it took only about 35 years. This is starting to sound almost feasible, a single lifetime. The crew could arrive at Andromeda, explore, and then make the 35-year return trip. But when they got back to Earth, over 5 million years would have passed. Everyone they ever knew would be gone. Human civilization would be completely transformed, and the planet itself might be unrecognizable. It's a lonely, one-way ticket to the future. Of course, reaching such speeds presents monumental challenges. The energy required to accelerate a starship to near light speed is astronomical, far beyond anything we can currently generate. Then there's the problem of interstellar dust. Even a tiny speck of dust hitting a ship at that speed would have the impact of a powerful bomb. The ship would need incredibly advanced shielding to survive. So, are we destined to be stuck in our own galaxy forever? Not necessarily. Science fiction offers us some tantalizing, albeit purely theoretical, solutions: wormholes. A wormhole is a hypothetical shortcut through space-time, a tunnel connecting two distant points in the universe. If we could create and stabilize a wormhole between the Milky Way and Andromeda, the journey could be almost instantaneous. You could step through a gate here and emerge in another galaxy moments later. However, right now, wormholes exist only in the equations of theoretical physics. We have no idea if they're real, let alone how to build one. But here's the most mind-bending part of this whole story. We don't actually need a spaceship to get to Andromeda, we just need to wait. The Andromeda Galaxy and our own Milky Way are on a collision course. Pulled together by gravity, they are hurtling towards each other at a speed of about 250,000 miles per hour. In about 4.5 billion years, the two galaxies will begin to merge. It won't be a violent crash in the way we think of it. Because the space between stars is so vast, direct star collisions will be incredibly rare. Instead, the two galaxies will dance around each other, pulled and twisted by gravity over hundreds of millions of years, eventually settling into one giant, new galaxy, which some astronomers have nicknamed Milkomeda. So, in a way, Andromeda is coming to us. Our distant descendants, if they're still around on Earth or somewhere else in the solar system, will witness the most spectacular celestial light show imaginable. The night sky will be filled with a breathtaking swirl of new stars as the two galactic cores merge. It's a cosmic event of epic proportions, a reminder that the universe is a dynamic, ever-changing place. So, how long does it take to get to Andromeda? With today's tech, longer than our sun is left. With futuristic tech, it might be possible in a single lifetime, but it would come at the cost of leaving your entire world behind. But the most certain way? Just be patient. In about 4.5 billion years, our cosmic neighbor will come knocking on our door. The universe is a big, beautiful, and sometimes surprisingly interconnected place. Thinking about these vast distances and timescales really puts our own lives into perspective, doesn't it? Thanks so much for joining me on this cosmic journey today. If you enjoyed this trip through space and time, don't forget to hit that like button, subscribe to the channel, and ring the bell so you won't miss our next adventure into the unknown. See you next time.